The Human Genome Project was the first attempt to map our genetic makeup. It began in 1990 and it ended, and the announcements were made in 2003. And Francis Collins was one of the visionaries that led this. I have a lot of respect for this man. He's done some amazing work. Don't necessarily agree with all of his conclusions, but I have a lot of respect for him as a man. Before the Human Genome Project, there was a belief in the life sciences, in biology, that it took one gene to program each protein in the human body. And because there are approximately 100,000 proteins, give or take, the thinking was, if it takes one gene to create each of those, that we would have about 100,000 genes. And the implications for that were vast. The pharmaceutical companies believed that if they could isolate those 100,000 genes, that they could create products that could target each of those individual genes. There's 100,000 new products. And in terms of disease and what it means for longevity and for, everything from cancers to diabetes to whatever is happening in the human body, the thinking was it could be addressed through understanding the map of these genes. What happened surprised everyone, because at the end of the Genome Project, it was discovered that the human body only has about 20 to 25,000 genes. That's not just a little mistake. That's not just a small margin of error. That is a magnitude, several magnitudes of difference from what was believed to be happening. And what it told the researchers was that something about their theory was wrong. And what they discovered is that it's not a one-to-one correspondence. It's not one gene for every protein. Individual genes have the ability to program different proteins. This is where epigenetics comes from. It is the environment that determines how the gene expresses and what proteins it creates. Some genes can create many proteins. And when I say environment, it can be the external environment or the world around us. So, those are toxins in the environment, can downregulate genes, and harmful UV radiation or radiation from a nuclear power plant, or, those kinds of things. But perhaps the most powerful environment is not outside of us, it's inside of us. It is the thoughts, feelings, emotions, beliefs. Stress is a powerful epigenetic factor that can upregulate or downregulate these genes. So with only 20 to 25,000 genes, we can program that 100,000 plus number of proteins that allows us to be who we are. That was a big deal, and scientists don't like to talk about that very much because it means everything they were teaching up until 2003 was based on this one gene for one protein principle. It was wrong. It was wrong, and it was hard for them to admit that. So I want to say that just about the Genome Project in general. It's amazing because it told us where we were wrong, and it opened the door to a powerful possibility of self-regulation. This is something that comes into play for a lot of advocates when it comes to Darwin's theory, because what this video was all about was the efficacy of evolution in general. And I'm just going to say to you straight up, as a scientist, I'm a degreed geologist. I believe in evolution. I support evolution. Evolution is a fact. I've seen it in the fossil records. I've seen it in insects preserved in amber in fluorescent Colorado. I have seen it in marine life. I've seen it in plants. I've seen it in animals. So I have no problem with the theory of evolution to explain certain forms of life. Here's where the issue comes in. Darwin's theory of evolution breaks down when it comes to humans. When it comes to us, scientists are pretty much in agreement, well, they were in agreement, that we appeared upon this earth about 200,000 years ago. A recent discovery has now pushed that date back to about 300,000 years. So scientists are pretty much in agreement that, let's just say that we humans appeared on Earth between 200 and 300 years ago. No controversy around that. The question is, how did it happen? They are in agreement that what are called anatomically modern humans, that's us, and the acronym is AMH. Anatomically modern humans appeared 200 to 300,000 years ago. The issue comes in terms of when we appeared and the way we appeared. We appeared relatively suddenly in the overall scheme of things. We appeared with a brain capacity, a brain size 50% larger than our nearest primate relative. We appeared with the ability for complex speech in a way that no other form of life and no other primate has. And these capabilities are due to mutations that happened in our genome in a way that cannot be attributed to natural processes. They cannot be attributed to evolution, at least as we know evolution today. Evolution through Darwin's perspective, or from Darwin's perspective, is slow change gradually over long periods of time. Stephen Jay Gould, another evolutionary biologist, put forth the theory of what's called punctuated evolution, where it looks like things aren't happening for a while and then there's a big jump and then nothing happens in the big jump. We don't really fit into any of those, and I want to talk to you a little bit about why that is, and it has to do with the genome. In the human genome, one of our chromosomes is a mysterious chromosome. It's number 2, and it provides a large percentage, I don't know the exact percentage, but a large percentage of the DNA in our nucleus, of our genome, is this it's the second largest chromosome in the human body. I know that. How chromosome 2 came to be is controversial, and it is mysterious. But let me tell you why it's important. There are about 12 to 1,300 genes on human chromosome number 2. I'm going to talk about only one of those genes. It's called TBR2. TBR2 is responsible for the brain size, twice as large as our nearest primate relative, is chimps and gorillas and apes. Twice as large. It is responsible for about 86% of the neocortex. And the neocortex in the human brain is where we attribute so many of the faculties that give us our humanness, our ability for empathy and sympathy and compassion, our ability to self-regulate our own biology. And so much of our mirror neurons, for example, are in the neocortex. Gene TBR1 is responsible for much of that. And gene TBR1 is the product of something mysterious that happened to create human chromosome number 2. If we didn't have chromosome number 2, we wouldn't be here. Now, what it is that happened to create human chromosome 2, this is where the mystery comes in. You've probably heard of telomeres. Some people pronounce them telomeres. The protective caps on the end of the chromosomes, so that each time a cell divides, that's a traumatic experience for the chromosome. And the telomeres take the hit of that trauma rather than the vital DNA information below the telomeres. So if you're going to have a cell division and a part of the DNA does not make that split, you don't want that to be a vital piece of information that programs your immune system or your circulatory system or something like that. So the way that we are made is that the telomeres will be the portions that don't make the cut, and all the vital DNA inside does. Those telomeres are on the ends of the chromosomes. So I'm saying this to you because in human chromosome 2, not only are telomeres on the ends of the chromosomes, they're also in the middle. And they are in the middle at a pinch point where scientists now know that 2 previously existing fully intact chromosomes fused together. So 2 pre-existing chromosomes fused together, and the fusion, where the telomeres used to be on the ends, they're now in the middle. But that's not where it ends. After that fusion occurred, there were genes that were silenced, is a term that's used when the genes are no longer active. There were genes that appeared to be removed, genes that appeared to be inserted to stabilize the fusion and to take away the redundancy. When you think about this, if there were two fully intact chromosomes, they were each doing their own thing, and all the functions were there. When you fuse them together, there is an overlap in function. There's a redundancy, and you don't want that. You don't want them working against one another. So there was a process where certain genes were either removed or they were silenced, or some others were activated. All of this happened in a very short period of time. Now, we know of nothing in nature that provides or allows for this kind of a fusion. Now, I want to be really clear on this because I know biologists are watching this. We do see a fusion of chromosomes in nature, and it's actually more common than you would think. However, the way that happens is a chromosome. So here, this pin is a chromosome, and the telomeres are the shiny places on the end. And every once in a while, something will happen and a chromosome will break in nature. It could be high UV radiation, it could be environmental toxins. So there are times where human chromosomes will break. And what happens is when they break, they will fuse at those break points. So the telomeres are still on the ends. There's no telomeres in the middle, and they'll fuse at those break points. That's not what happened to you and me. What is responsible for us, one of the things, is that there was the pre-existing, fully functional chromosomes that fused and then were modified after the fusion in a way that cannot be explained through natural processes. All right, that's one thing. Now, as strange as that is, if that was the only thing that happened, or as rare as that is, you could say, wow, that it's a fluke, but it happened. It's not the only mutation that happened. At the same time, there was another mutation that was happening in chromosome number 7. The result of that mutation gave us the ability for complex speech. It's the reason that chimpanzees cannot sing, and apes and gorillas cannot sing, but humans do. For over 75 million years, this chromosome, these genes in chromosome 7, they were stable, all right? And all of a sudden, there was a little, just this little switch in the DNA letters. You've seen the letters in what's called the genetic alphabet, C, T, A, G, that are abbreviations for the components that make up the DNA. There was a little switch in 2 of those letters that connected our tongue and the muscles in our jaw and the part of our brain that allows for complex speech and singing that happened only to us. It didn't happen to any other mammals, no other primates. It only happened to humans, and here's the kicker. It happened at exactly the same time, that 200 to 300,000 year range, when chromosome 2 was also fused together when humans emerged. So when we emerged, we were fully enabled and fully intact with the potential and the capabilities that we have today. They did not develop slowly, gradually over a long period of time. I did not see Francis Collins address that, and it's difficult to address that. What he did address was evolution in support of Darwin's theory for life in general, and I fully support that, because whatever we were, we inherited the DNA of those earlier forms of life. So yes, there is Darwin's evolution that played a role in the genetic makeup that led up to 200 or 300,000 years ago. But something happened 200 or 300,000, between 200 and 300,000 years ago, that cannot be explained by Darwin's theory of evolution, that precipitated the emergence of the first anatomically modern human. And that something is a mystery. That something is, along with the miscalculations in the genome, those are 2 things that I didn't see Francis Collins address in this particular video. Just to give you an idea, if you're a statistician, scientists say that the odds, when the odds of something occurring are 10 to the 400th power. So 10 times 10 times 10 times 10, 400 times. If the odds of something occurring are 10 to the 400th, scientifically that is said to be impossible. Those are considered to be impossible odds. If you had a lottery ticket and the chances of that lottery ticket being a winning ticket were 10 to the 400th, I wouldn't spend much time on that. Scientists have calculated now that the odds of our genome in general forming and chromosome 2, the way it is formed as part of that, that the odds of that happening are 10 to the 600th. If 10 to the 400th is impossible, 10 to the 600th is more than impossible. It's more than impossible that we're the product of random mutations, natural selection resulting from Darwin's theory. So the point is, if we are not the product of natural selection and random mutations, then what are we the product of? And this is what opens the door to a very empowering conversation. As a scientist, what I'm going to say to you is, scientifically, we do not know. Now, we have theories, we have opinions, we have intuition. Scientifically, we do not know. And the reason we do not know is because the scientific community is reluctant to follow the evidence to the story that it tells. Rather, they are very emphatic that they want to take the new discoveries, the new evidence, and force it into a pre-existing story that is called Darwin's theory of evolution, when in fact there's room for both. It doesn't have to be either or. Yes, Darwin's theory of evolution describes life in general and processes within life. Not 100%, there's some problems, but I think it does. It's the best that we have. It does a good job. I am not anti-evolution. However, I am adamant that something breaks down in the evolutionary story 200 to 300,000 years ago when it comes to us. We're the product of something, and as a scientist, I can only say this. It appears that we're the product of an intervention, an intelligent intervention. Some people call it a divine intervention that took the pre-existing forms of life, the most advanced pre-existing forms of life that existed at that time, and catapulted us light years beyond that. How that happened and who we attribute that to, that's a whole different that'd be another video. It's a whole different conversation, but you can see where religion comes in, because religion picks up with that intervention. Religion picks up with some kind of what is called a divine intervention, and that is one perspective of looking at this. Scientists aren't going to go after that, but they are now finding that they are at a dead end. And the only way to break the impasse is they have to follow the evidence. Who or what is responsible for us? Now, this is where, as a scientist, I have to leave the conversation. So what I'm going to say to you is not me as a scientist, it is me with informed speculation. So I will use my informed speculation, as well as some research that I have done as well. There are multiple, I think there are multiple explanations. One of those explanations is that we are related, as many of us suspect, to intelligence that permeates this cosmos that we simply have not been made aware of in recent history. That theory is supported culturally, almost universally. Every indigenous tradition, well, I will say this, every indigenous tradition that I've ever studied, I have not studied every indigenous tradition on the planet, but everywhere from the highlands of central China and Tibet and the monks and the nuns and the mystics in Nepal and India, all through the American desert Southwest and the indigenous First Peoples traditions, all the way with the time that I've spent in the Andes Mountains of Peru and on to the Altiplano of Bolivia, and their traditions, the Aboriginal traditions, the traditions that we find throughout Africa. Every one of those says to us that we are related to an intelligence beyond the physical planet that we live on. And I'm going to say it another way, not one of those traditions says that we're the product of random mutations. Not one. So that's culturally. Now, you may say that's not science, and that is a perspective, but that's culturally. Now, archaeologically, in the last 5 years, a growing number of archaeological remnants are being discovered, and I'm consulting on some of these projects, both as a geologist as well as a linguist, to understand what the script on these artifacts is telling us. But a growing number of artifacts are depicting our relationship with a cosmic intelligence. But the ancient Sumerian texts, if you're familiar with Sitchin's work, depict an interaction between us and cosmic beings. Now, Sitchin's perspective was that we were created as a race of slaves to work for a higher intelligence. While I suspect that we may have been enslaved at times in our ancient history, I firmly believe that's not the purpose. It's not the reason that we were created. And I think the evidence certainly supports that. But the point is that archaeological evidence is depicting this relationship that would support some kind of an intervention. So now we've got cultural evidence, we've got archaeological evidence. The fossil evidence has never supported Darwin's idea of evolution for humans. It does support the idea when you look at the evolutionary family tree and you see the lines connecting, Australopithecus and, Lucy and, the Lewis Leakeys and all the work that they did. Those are all solid lines connecting all those ancient forms of life. If you look closely, go to the Smithsonian map and you can see this. Modern humans, AMH, are connected to those through a dashed line. And if you look at the legend, what the dashed line will say is that these are speculative or inferred relationships. It means we think that they're there, that we just haven't found the evidence to support them. Darwin put forth his theory in 1859, after 150 plus years. If we were, it's been over 100 years, if we were on the right track to find the evidence supporting Darwin's theory, I think we would be further along than we are right now. We've had the best minds, the greatest scientists, the greatest sums of money, the greatest technology ever existing to help us to support Darwin's theory. And what it does, and this is where it gets tricky because there's nuance. It validates Darwin's theory for life in general, and I fully support that. It doesn't support our emergence 200 to 300 years ago. Something happened that cannot be explained by Darwin's theory. And this is where so many people fall. They say if it's not evolution, then it's got to be religion. I believe there's a middle ground. I think there's something that's not being accounted for. And that something is the intervention that happened in a way that perhaps we are the product of. And as we develop our potential, as we develop the untapped potentials within us, I think those potentials will lead us to the deep truth of the answer of who are we and where do we come from. This whole conversation is being pushed by the transhuman movement or the transhumanism movement. The desire to replace aspects of the human body with artificial intelligence and with robotics, ultimately with the goal of immortality. The only way that we can do that is that we must compromise our natural abilities. When we replace neurons with computer chips, for example, we replace natural blood with artificial chemicals, what happens is our natural abilities begin to atrophy and they die off, they disappear. Brain cells will die off, parts of the brain stop functioning. Research papers are very clear on this. This is the drawback of the transhuman movement that very few people are talking about. But the ability to augment our natural biology with technology is being made to look very sexy, very hip in mainstream media, and to young people that don't know any better and don't know any difference, and who have been conditioned to believe that we are a flawed species by virtue of our existence. This is what is taught, that carbon-based life is flawed and we are a flawed species, and that the only way that we can be healthy in our bodies and successful in life is by embracing artificial intelligence, computer chips in our brain, sensors in our skin, chemicals in our blood. That thinking is driving this transhumanism movement. The problem is that if we embrace it wholesale and recreationally, I mean, there are applications for all this that are beautiful applications for someone who's lost the use of a limb in battle in Afghanistan or in Iraq or in a car accident, to be able to have a computer chip in the brain and use the prosthetic to hold your child or to brush your own teeth or fix your own meal. I mean, what a beautiful thing. But wholesale adoption of transhuman technology holds the potential of forever taking away from us the very essence of our humanness. And we need to come to terms with that, and we can't do that until we know who we are and what it is that we're giving away. We haven't even begun to tap the potential of what it means to be fully human. And I will dedicate the rest of my life to doing my very best to share that potential and bring it forward as I come to understand it on deeper and deeper levels. And I know that other people are doing the same things. Evolution, for example, the DNA evidence, very recent, in the last 5 years, the DNA evidence no longer supports the theory of evolution as the mechanism for human origins. Evolution is a fact. Something happened 200,000 years ago, and the theory breaks down when it comes to humans. And the DNA shows us that. The DNA shows us very clearly that we did not descend from Neanderthal, for example. Their genome, we can now rebuild their genome and compare theirs to ours. We can actually, sounds like Jurassic Park, the movie. Science fiction, but it's science fact. We can pull the DNA from the bone marrow of fossilized remains of beings that we are supposed to be descended from and compare their DNA to ours. We didn't descend from Neanderthal. This is why I think it's so important, Brian. It's more than a philosophical conversation. Rachel Carson was an author in the 1960s. She wrote Silent Spring. She was one of the first environmental authors about the use of the pesticide DDT back in the 1960s. And she made a statement, I read this when I was a kid, and it was so powerful. She said, we only destroy the things that we don't value. The textbook says that life is a behavior pattern that chemical systems exhibit when they reach a certain level of complexity. That's the definition of life that we're giving to our young people in school today. When we begin to see what the DNA is telling us, it tells us something far beyond random genetic mutations is responsible for us. And that's, I think, where the change in thinking must begin. The facts that tell us that evolution, not only is not, but it cannot be our story. And if you look at the charts, the Smithsonian Institute, for example, and you look at those very well-known evolutionary family trees, we're up here and all these other forms of life, and we're connected through these lines. If you look closely, the lines are broken lines because they are called inferred or speculative relationships. They're believed to exist, yet no evidence has been found to date. And if we were looking in the right place, I think we would have found something. Within the context of the world that we live in today, this is the key. I firmly believe that when we begin to understand the truth of who we are, the reasons that we hate begin to vanish. The hate is based upon a way of thinking. We've been taught that nature, for example, the fundamental rule of nature is competition, conflict, struggle. And when I say that to an audience, they say, okay, Greg, big deal. Charles Darwin, he said that was 150 years ago, but hey, this is the 21st century. We have the internet. What difference does it make? And it's a really good question. And the young people, when I speak to the young people, they're amazed at the answer. And the answer is, yes, this is the 21st century. And the society that we live in today, the foundations of the society were put into place in the late 1800s, precisely at the time the theory of evolution was being embraced wholeheartedly by the scientific community. Our economic system is based upon this theory of competition. Our corporate system is based upon this theory. The way we share vital resources, energy, and food, and water in the world, it's all based upon this thinking of competition, conflict, struggle, scarcity. This is what we said to the UN. And as we globalize our world, and we're not turning back, we aren't going to go back to the world. I'm amazed how many people I talk to, some of my family members included, that say, this is a speed bump in the road of life. And they remember what used to be, and they say, well, when things get back to normal, we won't have these problems. I said, well, what do you mean? They said, when things go back to the way they used to be. We've never, as a society, we've never been given the opportunity to mourn the passing of the world that became familiar to us earlier in our lives. And that world is gone. And we cannot go back to a world that no longer exists. And as people begin to embrace that we are now living the new normal moving forward, this isn't a temporary speed bump in the road of life. So what would it be like, Brian, to have an entire generation of young people raised on this planet that believe that nature likes them, that they live in a world where they don't have to separate themselves from the very elements that constitute their bodies, that working together to achieve something is in harmony with the world around them rather than trying to beat someone else. And when I talk about competition, I'm not talking about a friendly game of chess or, soccer. It's what's called violent competition in the biological world. That is not the fundamental rule of nature. And the more violent competition we see in the world, that tells us how far we have strayed from the truest laws of nature's harmony. And that helps to see a lot of what's happening in the world. This is what we said to the UN. Peer-reviewed science, some of this published in British journals in the year 2016-17, was telling us that the new discoveries are that nature is, the fundamental rule of nature is cooperation. That is a 180-degree shift from everything that I was ever taught. What the DNA studies are now showing us is that the DNA that gives us our unique humanness, makes us who we are. The neocortex, I know some of your other guests have talked about, it's the largest part of the human brain, 6 layers of the brain. Very unique neurons, no other form of life has. What gives us those things is a fusion of DNA that happened 200,000 years ago. Chromosomes were fused together in a very precise way, and beyond the fusion, after the fusion happened, there were portions of those chromosomes that were added, portions that were taken away, and stabilized this fusion in a way that scientists tell us cannot be the product of evolution as we know it today. There appears to be an intentionality. And this is where science now is in forbidden territory, because if there's an intentionality underlying the way these chromosomes were fused, it implies a purpose. And this is where science is up against a brick wall right now, because that is beyond the purview of what science as we know it can tell us. If this happened only in one chromosome, you could see maybe it was a fluke. Chromosome number 2, human chromosome number 2, is the result of one of these fusions. Chromosome number 7 that gives us our ability for complex speech, changes in there all exactly at the same time, 200,000 years ago, which is not long, slow, gradual change over time as evolution would suggest. Something happened and we appeared fully intact, fully enabled, just as we are today, and we have not changed in 200,000 years. I don't know what did happen. That is not evolution. The scientific thinking has been that we need to find out what happened to understand the fusion. My feeling is just the opposite. If we follow, it's reverse engineering. I'm a scientist. I'm an engineer, software engineer. If we take what we have today and work backward to see what it took to give us what we have today, I think we'll find the answer. But you cannot do it in a vacuum. You can't only look in a microscope and say, here's what happened. You've got to look at the context, what was happening in the world, what was happening on the planet, what was happening in the cosmos, what civilizations were here, because nature doesn't know about those boundaries. Those are the self-imposed boundaries of our mind to put everything in boxes so that we're comfortable thinking about it. But if you remove those boundaries, there's a story that emerges, and it's a beautiful story. It's a powerful story. We're still writing the story. It's our story. And I think that story will lead us to transcend the hate. It will lead us to transcend the war. And that's, not only is it interesting, I think it's vital. We must embrace the deepest truths of our existence if we're going to move forward as a planetary civilization. And this is what my work, every facet of my work in some way addresses. As a scientist, when I look at nature and how nature accomplishes huge change, there's a pattern, and we are following that pattern right now. And what happens always in nature is this, is that the system becomes more and more and more complex, just as our world has become more and more complex, until the complexity is no longer sustainable. And then the whole thing goes into chaos and breaks down. But it doesn't break down to zero. It breaks down to give way to a higher order. I believe that we are globally in that natural process. Well, I've never been more optimistic, because I think the fact that these things are breaking down in the presence of the information age is the key. If we did not have the information age and they were breaking down, I think it could go a different way. But as these things are breaking down, we have something to fall back on. Our plan B, as you've heard me talk about, my plan B, Our plan B is already out there. We know there are other ways to do economies that are not based in competition. We know that there are other ways to create energy that don't destroy the environment. We know. I'm a realist as well as an optimist. And realistically, we are living a difficult time because we're in the middle of the breakdown. And if you don't get a higher perspective, if you just look at what's happening right now, it can be overwhelming. It can be frightening. If you sit back and you look at where we are, how quickly we've gotten here, and what the potential is, and you begin looking at these cycles, seeing the climate. When I look at the climate cycles, I'm really encouraged by what I see in geologic history. They are intense, but they're brief.
Okay.
They don't go on and on and on. We're living a brief, intense period of change. Something's going to give, and that give allows us to go to a higher order. We largely know about climate through the ice cores from Antarctica and Greenland for long ranges of time. Shorter ranges of time, you can look at things like tree ring cycles, maybe go back 2,000 years or something like that, but they're not as accurate. So we're looking primarily at ice cores. What the ice cores tell us, they go back 420,000 years before present. The ice cores clearly show rhythms of cooling and warming for both temperatures and rise and fall of CO2. They clearly show that. Before this was politicized, scientists were all on board with what I'm saying right now. They also show that the temperatures typically rise first, and then the greenhouse gases rise after that. We see that in the Vostok cores from Antarctica, which means the CO2 is not the cause of the warming. We also see when the CO2 levels are high, the temperatures actually begin to cool more. We're actually in a global cooling. It doesn't mean the whole planet cools all at once, but overall, a global cooling. My concern is if the Earth cooled as much as it cooled in the past from the natural carbon dioxide, and we are contributing so much to that carbon dioxide right now, what is that going to mean for our future? So have we contributed? We have to say we are, because we're kicking tremendous amounts of CO2 into the atmosphere, and it definitely is accelerating whatever change is happening, both the warming and the cooling. So to be very clear, global warming is a fact. I'm not denying that. We need to stop burning fossil fuel. We need to go clean, green, and we have the technology. We could do that today if we wanted to do it. If politics and money were not a factor, that could happen. Did we cause global warming? Warming is a part of climate change. We're always going through warming and cooling cycles. We didn't cause it, and we're not going to stop it. Do we need to change the way we live? Absolutely. The moment I started speaking about spirituality as a scientist, I lost my credibility as a scientist. Science likes to work in boxes. What I choose to put into my body, I learned a long time ago, is more than just filling the empty space of my stomach. When I was researching the ancient texts, there was a sect called the Essenes, the ancient Essenes. Mysterious sect 500 years before the time of Jesus. Jesus, as a teacher, was taught in these Essene, E-S-S-E-N-E, Essene traditions. They were called therapeutae by the Egyptians because they understood healing. And when the master, Jesus, when he was asked by his students, what should we use to nourish our bodies? He answered them in a way I think it was so profound 2,000 years ago. And every meal I think of this. He says, if you put living food into your body, it will give you life. And if you kill the food that goes into your body, that dead food will also take the life from your body. And I can't think of a more profound way of saying the closer that we can eat to the raw and natural foods, processed foods aren't really foods. They fill the space, but they're not really food. So non-negotiable for me, the best quality of food that is available for me in the moment. If you're on an airplane, and for a few hours in the air, I have to eat something a little different, and that's the best I have in that moment, then I'll have that, and it's fine for me. And then when I get to wherever I'm going, I'll have something that's really good. So the nourishment and movement. When I'm at home, I prefer raw vegan. It's very difficult to eat raw vegan, and it's just about the quality of food. As little processing as possible. I don't do a lot of creams and sauces, and in other words, I eat for nutrition, not necessarily for taste, but I've learned that when something's really nutritious, it tastes awesome to me. So a salad, for example, rather than covering it with a lot of stuff to make it taste different, I've learned, and to me, the salad all by itself tastes really, really good with no dressing on the salad. Every lettuce has its own flavor. You know, a Bibb lettuce is different than a radicchio, you know, and carrots are different all over the world, and you know, and I love that. So kindness, I think, is really, really important. We can be honest with other people about what we're feeling and what we sense in the moment, but there is a way to share those feelings that can be done kindly, or it can be done in a hurtful way. And I think honesty, I believe there's a responsibility being a public speaker on a stage. When I'm looking out in the audience and the 2,000 or 3,000 people out there, and I know some people that have come to listen to me can be in very fragile places in their lives, be in very, very delicate places. And I have to ask myself, when I'm going to share something, what is my intent in sharing this? Who does it help? Who does it hurt? How is it heard? And is there a way that I can share this still honest, but in a way that is non-judgmental, that is not hurtful? And I'm a student of learning what this, and I'm also a student of listening. I've learned to become a good listener, and I'm still learning. And I've learned to listen from the people that I spend time with. What words work for you and what words don't? And it's different. So when I speak to, we're doing pilot programs with young people, and I have to use a very different language to elementary school and middle school, high school. I work with elders sometimes, very different language with elders, and they have a very different attention span. When I'm with my typical audience, I can use my scientific language or lingo. If I'm with a technical audience, I'll use a different language. So it's about honoring those in my presence with a way of communication that's meaningful to them. I'm at a point in my life where I honestly have to say I'm not afraid of anything. And I also asked what mistakes I've made in my life, and I believe I've made no mistakes. And I'll tell you why I believe that. I think some of the outcomes could have been maybe better than others. Work is love made visible. 10 years old, I embraced that philosophy. And what that said to me was, whatever I say yes to, if I say yes that I'm going to do anything, if it's a video, a book, if I'm loading a boxcar or whatever it is, if I say yes, that means I'm committed 1,000,000%, and I will do my very, very best. And if I've done my best and I cannot do better, and it doesn't turn out the way I expected, it cannot be a mistake, because I did my very, very best. If I entered into it anything less than that, it could be a mistake. If I went into something and said, I don't really want to do this, but I'm going to do it anyway, or they're only paying me a little bit, so I'm not going to give them as much, that's not honoring my commitment. And that's where mistakes can happen. So I honestly can say I feel I haven't really made mistakes. I have had learning experiences. And when I think about the world today, I was just asked this recently, I can't really think of anything that frightens me, because there's a part of me that knows that I have within me the ability to transcend whatever it is that life brings to my doorstep. And I had to learn that through going through what are called dark nights of the soul. I've had a couple of them in my life. And you come out on the other end. You can come out devastated, or you can come out stronger. I was blessed to come out stronger, and in that strength, it has empowered me to see life differently and to think of life differently. And I really think that for me, I think it's true for everyone. I believe not everyone has reached the point where they see it the way that I'm seeing it, but I think everyone has the ability not only to survive, but to thrive in whatever life brings to their doorstep, and to transcend those circumstances. You and I are living in a world that is changing very, very quickly. There's no secret there. My world is changing, your world is changing. But here's the thing, we're being asked to make choices, and we're being asked to make decisions that we've never been asked to make before. And for the most part, we have been poorly prepared to make these decisions. We're being asked to embrace policies that we know very little about. We're being asked to enact laws that determine how we live our lives based on information that we really may not even understand. We're being asked to elect officials to represent us in the form of government that we have that are supposed to reflect our belief systems and our values. Well, how can we do that? How can we do that if we don't have the information? So the whole point of this series, and the reason I've developed it, it's based on a simple premise. The premise is this: when the facts are clear, our choices become obvious. Think about that. When the facts are clear, seldom do we need to be told what to do, because we say, of course, it makes perfect sense to do this thing or to think in this way. What I've found in my life is typically when the decisions are the most difficult is because I don't have all the information. You and I are being asked to make difficult decisions, and we're being told how to think. There's a battle playing out. You know that. I've talked about it in other programs, other episodes. There's a battle for our thoughts. There's a battle for our beliefs. There's a battle for our very humanness. High tech is leading us to believe that we are vulnerable, fragile, frail humans, and we must replace our natural extraordinary biology with AI, artificial intelligence, computer chips, wires, chemicals. Climate is especially important because it touches something so primal within each of us. We all love this planet. We all want a better world. We all want a good life for ourselves and our families. And we are passionately going about the things that we believe will lead us to that end. But what we're doing is based upon the information that we're being given. And this is what is tearing our families apart. I'm seeing families, I'm seeing husbands and wives separate and divorce. I'm seeing parents and children that can't find common ground in this. It's tearing apart communities. It's tearing apart our society. It's tearing apart our nation. It is shattering our world. What is happening with climate? And it's causing such divisiveness. The elders, people in my generation that were speaking to a younger generation, rather than inviting them to embrace data and make positive change, they incited them to become angry about the injustices that had been done based upon false assumptions of obsolete science. And those young people were then empowered to go and destroy property. They felt justified in destroying the property that they felt was contributing to the lies of the climate change that they had just been told in this public forum. So this is an example of where I think it's so important. It all comes down to this fundamental question: how can we solve the problems if we're not honest about the problems? If we really want to solve these problems in a healthy way, we've got to be honest with ourselves. What are we afraid of? What have we got to lose if we are honest with ourselves about the change? Now, when it comes to climate, and I am really passionate about this, Earth is a dynamic system, and science is a dynamic system of knowledge. Science is designed to be constantly updated, and Earth is constantly changing. We are constantly having new research and new data that helps us to update what we have been led to believe about climate. So when someone in a position of power and authority says to me through the mainstream media, discussion is over, we can't talk about this anymore because the data is in, the discussion is over, finished. I am very suspicious of that person and their motives, because science is designed as an ongoing discussion. It's a conversation designed to be constantly updated and honed and refined based on the new data that comes in. So this is why I think this particular episode is a very powerful episode, and this series is important, because I am an independent researcher, an independent author. I'm not affiliated with any university or any academics, with any corporations, with any religions, with any organizations. I have nothing to lose by sharing with you what I have found as a scientist and a researcher. And when it's updated, I will update that with you. And when information overturns what I have said to you, I have no problem saying to you, I made the decision based upon what I knew in that moment. And as new information comes to me, I'm going to share it with you. This is how it works. And this is the healthy way for us to move forward in dealing with the change that we see in our life and our world. One of the best ways to understand our relationship to the climate of our planet in the present is to see how it fits into our relationship with the climate of the planet from the past. And this is one of the things that led me to become an earth scientist, to become a geologist, because I'm fascinated by the fact that we can look into the history of the earth, and earth will tell us her history in her own language if we have the wisdom to understand that language. And in the language of the southern Andes Mountains of Peru, Pachamama, Mother Earth, tells us her story. She reveals her past through records that can be read like you read the pages of a book. And as a young scientist, I was fascinated by this, not just because it's interesting, which it is, but because it also helps us to understand us. How have civilizations been influenced by climate in the past? When did great civilizations end, and when did they begin, and how does that relate to climate? What we find is climate change has driven the collapse of massive civilizations in the past. As the climate changed, food became scarce, competition became the way that people were working, and it led to war, and the war is what ended those civilizations. That is important because we are in those cycles, and the question is, are we making the same mistakes as we have seen in previous civilizations? Can we recognize those? Can we make new choices? So one of the best ways to understand climate in the past is through what are called the ice cores. Every year, a new layer of ice is deposited in the cold regions of the extremes, the Greenland ice caps north of the equator and Antarctica south of the equator. And this is what the ice cores look like. I wanted you to see what an ice core looks like. I was surprised the first time I saw one. They're bigger than I thought that they would be. And from these ice cores, we can discover a whole lot of information. You would be amazed at what we can discover. And think about the reason. Every year when that ice layer forms, it captures little bubbles of air from the atmosphere. And in those bubbles of air, we can tell exactly how much carbon dioxide was in the atmosphere for that year, how much oxygen was in the atmosphere. We can tell if there were volcanoes on the planet because volcanic dust will be in that ice. We can tell if the pollen grains carried by the jet stream or by some other air current from one part of the world, we can tell what was happening in that part of the world because those pollen grains will be in the ice. We can tell what the temperatures were, how hot or how cold for that year, how high were the sea levels, how low, how strong was the sun, how strong were the magnetic fields, so much more. So you get the idea. So from the ice cores, we have a record of our past. Now I want you to see, this is a close-up of what an ice core looks like. So you can see those vertical bands that you're seeing. Each band represents 1 year of Earth's history. The dark bands, obviously, something was happening. Maybe an asteroid struck the Earth and kicked a lot of dust into the atmosphere, or maybe it's the dust from the Sahara being blown by superstorms, or maybe it was a meteorite, or fires, great fires swept the Earth. All that's recorded in the ice. This information can be read like the pages of a book, and it's not surprised they're kept in what is called an ice core library. And there are multiple libraries. You're seeing one right here. So scientists can come and they can pull out these ice cores like you pull out a book in a library, although a lot of this is digital now. So they don't have to actually pull out this ice core any longer. All right, so let's get to the heart of this. What is the ice core telling us? I'm giving you peer-reviewed data. I want you to know these are not my theories. It's not my hypothesis. It's simply science that you rarely see in the mainstream. You won't see this in mainstream media. It's not popular. It doesn't support the narrative that is being perpetrated in the mainstream media. So I'm giving you the full references here. This is from peer-reviewed data that was published in the very prestigious journal Nature, volume 399. I'm even giving you all the researchers. Usually you'll have the name of one, and then it'll say et al, which means, there are more. I want you to see all this here. There's no secrets here. What you're seeing is this. So let's start out. This is a graph showing data of temperature changes. Now, I'll be really clear. This is not absolute temperature. These are variations in the temperature above and below the normal from one ice core, and this is from Epica, EPICA, in one location in Antarctica. It begins on the right-hand side, goes back 450,000 years before today. On the left-hand side is today, is present day. So all I want you to see from this, can you see that there are rhythms and cycles? And if you can, you're right on, because there are cycles within cycles. There are 5,000-year cycles. There's the 10,000-year cycles, 26,000-year cycles, 41,000-year cycles, 100,000-year cycles. And you say, well, Greg, maybe it's a one-off. Maybe this is an anomaly. What you're seeing in the green is a second ice core, a very famous ice core from another part of Antarctica, about 300 miles away from the Epica ice core. What you see in the green, it's the Vostok ice core. All I want you to see from this is, can you see how it agrees in general? The closely correlates. It parallels what you see. The green parallels what you see in the blue. So this is pretty good data. And the red at the bottom is very intuitive. What you're seeing, I'll show you, I think you can see the cursor from my computer here. What you're seeing is these are variations in temperatures. When the temperatures rise, like you're seeing on the green and the blue, what would you expect would happen with the ice? The warmer temperature would melt the ice would collapse, and look at that. This is exactly what you're seeing right here. And then when the temperatures are low, you would see the ice gradually build. It's exactly what you're seeing until they reach a warm place, and then the ice collapses. So this is, the red is the thickness of the ice compared to the temperature. All this comes from the ice cores. All right. So 450,000 years ago is how far back the Epica goes on the right. We are here on the left, right there. And I'm just going to say you are here. What this says, according to these, the historic records of the temperature anomalies, it says that we should be in a warming period, and we are. I would be concerned if we were not having some degree of warming. I would say, why not? Because we're due for it, according to these cycles. So are we the warmest we've ever been? Not according to what these charts are telling us. We are warm, but there are cycles in the past where the difference in the temperature has been much greater than it is today. The other thing that I want you to note here is that when the warming does happen, or the cooling, this happens on both ends. When the warming happens, it's intense, but it's brief. It doesn't last long. It doesn't like drag on and on and on in a plateau. It's a peak, and then it's what comes next that's often the problem, because from the warming peak, we go into cooling cycles. Not necessarily an ice age every time, but definitely cooling. And it doesn't take much cooling to change the way that we live our lives, especially north of the equator, where most of the land mass is found, most of the population of the Earth lives, and most of the food is grown north of the equator on the Earth. So what is the role of climate change in the world that we're seeing now? And I think we answered that. Are we the cause? This is the big question right now. Let's see what the data is telling us. We see these rhythms in the Earth going back from here over 450,000 years before present. Scientists are in agreement, so this is not controversial what I'm going to say to you, that anatomically modern humans, you and me, the way we are right now, we showed up on Earth about 200,000 years before present. Now, I know there are other belief systems that give different dates, and there are other interpretations. I am sharing with you peer-reviewed science to honor you in this conversation. And I'm not discounting anything else that's out there. I'm choosing to share with you the scientific model so that we can have this conversation based upon facts rather than speculation. All right, 200,000 years ago, I'm going to show you where, here's the line right here, 200,000 years before present. So from that blue line to your left, to present day, we have had the opportunity, the potential to contribute to climate change through industrialization that has happened in that 200,000 years. But look at this. Look at that blue line to the right. Science tells us that anatomically modern humans and modern industry did not exist during that time, but the cycles were still there. So if we're honest with ourselves, are we the cause of the climate change because it was happening when we were not on Earth? We have to say that we are not the cause. You're not going to see this in a lot of mainstream. It's based upon peer-reviewed data. You've got the source for it right here. So what this is, may look a little technical, but I'm going to break it down really quickly. In the blue, what you see are the temperature, the rise and the fall of the temperatures. In the green, right below, what you're seeing is the rise and the fall of carbon dioxide based upon the data from those ice cores. Now, is there a correlation? Absolutely, there's a correlation. Right on, man. You can see a correlation. Correlation is not causation. All right. Just because the data correlates doesn't mean that one necessarily caused the other. All right. And what you're seeing here, I'm going to invite you to look closely. Let's take a look at one of these peaks right here. And I intentionally offset in this first line, I offset the red a little bit so that you could see where the peak is. I mean, if we move that over, you can see there's the peak in the temperature. And what you see is that temperature peaks before the CO2 is peaks. Even if I move that over a little bit, it would be like right here. The temperature rises before the carbon dioxide. Well, you say, well, wait a minute. I thought the greenhouse gases are causing the warming. I thought the CO2 is causing the warming. It's not what the data suggests. All right, I'm going to share with you what the data does suggest, but I'm just going to go through this step by step. You say, well, maybe that's a fluke. Did it happen somewhere else? Well, yeah, look at this. Everywhere where you see a rise in the blue, in the temperature, the CO2, it rises, but it lags. The temperature rises first, and then the CO2 rises. All right. Seeing it right here. And I could go through all of these. I didn't, but I did enough to show you. Now, this one is interesting because look at this. The temperature is rising. Look at what the CO2 is doing right here. I'm just going to back off. There's the CO2. It's actually dipping. The carbon dioxide is low and the temperature is rising. All right. And look at these big peaks over here. Here, the temperature is rising. CO2 is rising, but it lags. The temperature is rising, the CO2 lags. Look at this. You see it right there. It's happening throughout our past. Now, this surprised a lot of scientists. There's a reason for this. And I want to be really clear. This is a tricky conversation. It's delicate. This is not climate denial. It's just the opposite. The fact is, climate change is a fact. We need to adapt to climate change. We are not the cause of the climate change. Are we contributing? We have to say that we're contributing because we are kicking carbon dioxide into the atmosphere. Is carbon dioxide causing the warming? This data says that it's not. All right. Now I'm going to show you what that means here in just a moment. But let's look at this. Here we are right here. I made a different color line on the far right. Here's present day. And look, when our warming began, all right, so here's our warming beginning right down here. And you're seeing this warming. The same thing is happening. The CO2 lags. Now, there are charts and graphs out there that are showing you 10-year histories of the Earth or 80-year histories of the Earth. Mother Nature, geology does not work in 10-year or 80-year cycles. Mother Nature works in vast cycles of time. And I think it's very disingenuous to take that data in these snapshots out of the context of the big picture. That's called cherry picking the data. And there's some people that are really good at doing that. So what you're seeing is we are in a warming. There it is right there. The warming began before the CO2. And it's not your imagination. I want you to know, I want to show you the chart and where that came from. Here is the peer-reviewed data. Here are the scientists telling us this. Here's the title, Vostok Ice Core Climatic Response to CO2 and Orbital Forcing Changes Over Last Climatic Cycle. This is one of the reasons that you don't see this in the mainstream. Look at the title of this article. I mean, who has a beautiful hardbound copy of this article on your bedstand for light bedtime reading, like I do? They're very complex articles, and that's why they're often published in obscure journals. You don't see a lot of this in the mainstream science, but look at what it's saying. Look at this. This is a direct quote. When going from interglacial to glacial conditions. I'll stop right there. What does that mean? Glacial conditions are when the glaciers are prevalent on the Earth. We are not in that now. We're in between. So we are in the interglacial. So when going from where we are now, from interglacial into glacial conditions, now look at this. Look at what this says. The change in carbon dioxide concentration actually lags the change in the air temperature. All right, they're telling us, right? This is rock solid, hardcore science. These are not politicians. These are not people who have an agenda, a political agenda, or a domestic agenda, or an economic agenda, or a religious agenda. These are scientists doing their job. The carbon dioxide lags the change in the air temperature, and you just saw that. You saw that in the chart. All right, so I'm going to move quickly. If the carbon dioxide is not the cause, what is? Scientists have known for most of the 20th century the answer to this question. A lot of scientists don't like this answer, but they're now being led to a place where they've got to embrace what this answer is saying. You know, we ask science to tell us who we are and about our relationship to the world, and science does that. And sometimes there's some scientists that don't like the answers and push back on those answers. There was a mathematician, his name was Milutin Milankovitch. You know where this is going if you are familiar with Milankovich's cycles. He identified cycles that are very probably the trigger for the climate change. Now, when I was in school, I have to say this, back in the 1950s, 1960s, early 1970s, when I was in school, I remember a colored picture in my geology book of the sun in the middle of the page, and then Earth making an orbit around the sun, which it does, but that orbit being a perfectly circular orbit, and Earth looking exactly the same orientation everywhere in that orbit. That simply is not true. Earth does a dance as Earth orbits the sun, and that dance has three primary movements. Those movements change our relationship to the sun, and that is what scientists now suspect is the trigger for climate change. Here's what I mean. Milankovitch cycles. The first of these movements is called the precession of the equinoxes. It's a 24 to 26,000 year cycle, huge cycles of time. Precession, I'm going to invite you just to hold that in mind for a moment. The second is one of the biggest, probably has one of the greatest influences, is caused eccentricity. So what you see here, you see the blue line that depicts the Earth's orbit. Here's the sun in the middle. And you can see that sometimes if we were here, we're closer to the sun. Sometimes we're further away. All right. That means different times in the orbit are relative to where the sun is. And those differences range from 100,000 years to 413,000 years. So that is the eccentricity. And the third is what's called obliquity, or simply the tilt. And this is about a 41,000 year cycle. So all I want you to see from this, precession, eccentricity, obliquity. Here it is graphed on a chart. Precession, eccentricity, obliquity. And what you're going to see right at the bottom is the warming and the cooling of the Earth as it relates to these cycles. So here's how this appears to work. When one or some combination of these peaks line up, Earth goes through some climate change. And it happens all the time. Sometimes it can be simply this eccentricity seems to be driving a lot of the effect. So let's look at what we're seeing right here. Let me just show you. Right there. Okay, what you're seeing, I'm going to back it up so you can see it. The peak of that blue is lining up with the peak of the red right there. Can you see that? All right. And so when precession and eccentricity are lined up, look at what happens down here. You've got warming. You say, well, Greg, maybe that is a one-off. Maybe it's a fluke. Well, look at this. Here's right in the peak of the eccentricity. I'm going to back this off so you can see it. There is also the peak of the obliquity right there. And you're also seeing the peak of the precession. So all three line up right here, and you've got some warming. This happens all the time. And this appears to be what we're experiencing right now. So where are we today? Where are we right now? Here's 1,000 years ago. Here is present day. And look at what's happening. I don't know if I didn't draw a little line there, but here's us right here where the cursor is. And look at how minor our eccentricity is compared to where it's been in the past. We are experiencing relatively minor climate change. Now, it's big to us. because we're not prepared for it. It's big to us because it's different from what we have been led to experience in the past. We've been led to believe that Earth is a static system and that the seasons always happen at the same time, the climate is always the way it is, and when that varies, we think something is wrong or something is broken. And that belief can be hijacked and used as leverage for political agendas. So are we causing this warming? As a scientist, I have to say we are not the cause. The data simply doesn't support that. It suggests that the Milankovitch cycles are the initial cause. Now, here's how this works, and I don't want to get really complex, but I want to be very clear. It appears that the Milankovitch cycles begin the climate change. So they trigger the warming, and that's why the warming happens first. And then you see the CO2 start to rise, because when the warming occurs, it warms the land, it warms the oceans. When the water is cool, it holds more carbon dioxide. As the oceans begin to warm, they begin to release carbon dioxide into the atmosphere. And we are now contributing in that part of the cycle. We are contributing to the carbon dioxide that is naturally released into the atmosphere through these cycles. All right. Climate change is only a problem if we're not prepared for the climate change. There's something called normalcy bias in psychology, where when an individual is confronted with a change that is so massive and it represents such a perceived obstacle, the tendency is just to discount the change, to try to live life as if that change were not occurring. We're experiencing normalcy bias when it comes to climate change because we are being asked to continue living just the way we've always lived in the presence of extremes in weather and local weather and rain and snow and heat and cold and floods and ocean levels. It makes sense to expect those extremes because of where we are in the climate change. And if we adapted accordingly, there would be much less suffering. And I believe that we would have a much different experience of what the climate change is leading us to experience right now. If we're honest with ourselves, we have everything we need, not just to survive, but to thrive, to transcend and become better people, create a better world. We have all the information. The question is, are we willing to embrace the information that we've asked science to provide us? And this is important because our world is changing. Boy, is it ever. It's no secret to you, your world is changing, my world is changing. Why am I sharing this with you right now? I'm sharing it with you now because there's a battle unfolding in our lives, and you and I are part of that battle. Whether we like it or not, and whether we're even aware of it or not, there's a battle for our thoughts. And I think you know that battle is playing out in the media. There's a battle for our story. There's a battle for our very humanness. And what we're being taught are the capabilities of our bodies in the presence of the world that we now find at our doorstep. But the key here is that we're being asked to make choices. And my question is, how can we possibly make choices of the magnitude that we're being asked to make? How can we know what laws to embrace, what policies to enact? How can we know what choices to make in our lives until we understand the science that's underlying those choices? I know that you know there is misinformation, there always has been, honest mistakes that come from people in the media that are not well versed in the science. But something new is developing now. We are experiencing disinformation, where information that is known to be false is being shared when it comes to science in the scientific world. As a scientist, I have to tell you that science is a language that is relatively recent that we use to describe our world. We say that the scientific method began about 300 years ago during the time of Isaac Newton, when he formalized the laws of physics. Now, I'm not going to say that there weren't scientific principles that were playing out before then. Some would argue that even Socrates was using scientific methodologies to explore the mysteries that he saw in the universe in his time, but they weren't formalized as the scientific method that we know today. So science is a language, and it is a relatively neutral language. It's a language that doesn't carry the baggage that so many of our other ways of knowing may carry. Religion, for example, or spirituality, for example, or one particular ancient civilization or one particular ancient culture. So science, I think, has the power to inform us without triggering our emotional reactions to so many of the concepts that have created our story. We are steeped in a story from the time that we're born. And that story informs us when it comes to the relationships we choose, how we heal our bodies, the jobs that we feel that we're qualified for, the way that we think about the world. Again, it all comes down to our story. Science is designed to be updated. Science is not a static story. New discoveries are meant to be incorporated into an ever-evolving scientific story. That's not what's happening in our world today. We are being asked to believe that science is static, that the science that I was taught when I was in school in the 1950s, 1960s, 1970s, that science, much of it's still being taught in the classrooms to our young people, to your kids today, even though new discoveries have overturned that science. The science when it comes to who we are, for example, where we've come from, what are our origins, the origins of the cosmos. But the science is so important right now. And here's the reason. Based upon misinformation, disinformation, obsolete beliefs from false scientific understandings, we are being asked to embrace policies. And the way we've been taught to think about those policies is causing struggle and suffering in our lives. And you all know that. We are seeing families ripped apart from misinformation. We're seeing communities ripped apart. We're seeing young people that feel justified in destroying a property that may be creating carbon dioxide, kicking it into the atmosphere, for example. I'm just using this as an example, because of what they've been led to believe about the role of carbon dioxide in climate change. Now, I want to be really clear about where I'm going to go with this, and then we're going to jump right in. We need to go clean, green, sustainable energy. We have had the technology to create electricity for everyone that wants that electricity, every home in every nation, on every continent, on the face of the earth. We have had the technology to create clean, green, sustainable energy with zero fossil fuels, zero greenhouse gases. And we've had the ability to do this in ways that cannot be weaponized, like the plutonium that comes from the uranium in nuclear plants, for example. We've had the ability to do that. We've had it for over 70 years. If the powers that be were serious about moving us forward into a clean, green, sustainable world, my personal feeling is that they would bring those technologies forward. For a lot of reasons, it simply has not happened. But I want you to have the science, and I am not beholden to any organization, so I have nothing to lose by sharing with you the facts as I have come to understand them. I'm not beholden to a university or to a corporation. And that's important because in many respects, modern science has been hijacked. It has been hijacked by corporations, by politics and politicians. It's been hijacked by religion. It's been hijacked by economists. These people and organizations are cherry picking very specific pieces of information to change the story that is being shared in the mainstream. This is part of the information war that you and I are part of. So I am not naive in thinking that we are going to stop that war, but I am very passionate. I'm feeling very passionate because I am seeing friends, family, loved ones that are just feeling torn apart by what's happening in the world today. They don't know what to do. They don't know who to believe. They see a friend send them something on social media, on Facebook or Instagram, that tells something, and then another friend sends something that gives them a different story, and then they read something somewhere else. They are exhausted. They are emotionally exhausted. And I know you're seeing this in your community. People are just worn out from the battle that's playing out on the political level, on the scientific level, and certainly now on a social level. Climate change is a fact. I have been saying that climate change is a fact since I was a geologist in the corporations back in the 1970s. Climate is dynamic. Climate is not a static experience. Earth's climate is always changing. So the questions that people now are asking me, that I'm going to be answering for you with the information that we now have available, is what is the role of the climate change that we're seeing in our lives now? What is our role in that climate change? Did humans cause it? Are humans contributing to it? Can humans stop it? Do we want to stop it? And if climate change is not happening for the reasons we've been led to believe, then what is causing climate change? What does that mean in our lives? Where can we go from here to create that clean, green, sustainable energy that we all know is possible? And I think the answers to these questions may surprise you. When we talk about climate, climate is one part of a dynamic system. Earth is made of much more than simply the climate that determines the weather in our local experience. So climate is the general conditions that determine the localized conditions that we call weather. When the climate changes, the weather changes. It changes when it's warm, when it's cold, when the seasons begin, when they end, when it rains, when it snows, the temperatures, when we plant, when we harvest our crops. And this is one of the reasons that understanding climate is so important. In the very prestigious journal Nature, volume 461, and you're seeing the reference at the bottom of your screen, researchers published a peer-reviewed article entitled Earth's Safe Zone. And what they did was they identified the 9 planetary boundaries, the parameters that must be in place for us to live on Earth in the way that we have become accustomed to, for life to be sustained upon the Earth in the way that we have known it in the past. And the reason I'm saying this, climate is very important, but we're being led to believe it is the most important. It's the most important thing, and that we have very little time to reverse what's happening with the climate. Well, let me give you a perspective from this piece of research. What Rockstrom and his team share with us in this very prestigious journal, again in the volume Nature, is there are 9 planetary boundaries. Climate is only one. So here they are right here. Why don't you take a look at these 9 planetary boundaries, and I'm going to talk about each one briefly, but what you'll see is that radiating from the center of this sphere outward are concentric circles. And the color coding that you're seeing now below the chart tells you where we are in terms of those boundaries. Are we within the safe zone? Have we exceeded the safe zone? So let's talk about climate change right here. You see it right at the top of the screen. Climate change is important. It's acknowledged on this chart. Right now, we are in a zone just bordering on a zone of what we call uncertainty and increasing risk. We need to be aware of it. We need to do what we can do to mitigate our contributions to the climate change. From this chart, it is not the most of our worries right now. As we begin to move to the left in a counterclockwise direction, look at this. Biosphere integrity. If you look at where this chart is, we are off the charts in biosphere integrity. It means we've crossed this planetary boundary already. What is biosphere integrity? And you're seeing genetic diversity. What it means is that we're losing species on this planet faster than we can even catalog them. And many of those species we are losing are in the ocean, and this is important because the ocean creates the food chain that much of our 7.8 plus billion people in our global family depend upon. This is where our food comes from. If the food chain in the oceans break down, that breakdown has a ripple effect up through the larger animals that we depend upon, so much of us depend upon for food and on our planet. This is critical. My dear friend, my colleague, Dr. Bruce Lipton talks about this and tells us that we are in what is called the 6th mass extinction on planet Earth. There have been 5 in the past, documented, we know those. Many of those were from natural causes like asteroids, climate change. Problem with this is that this extinction that we're in right now is because of us. It's because of human activity. So we've already crossed the boundary with biosphere integrity. Land system change, we are moving in a direction of concern. You can see it's yellow, in a zone of uncertainty. This is the way that we use the land, how much of the land we cover with asphalt and concrete, how much of the land disappears and is not allowed for moisture from rain, for example, to seep into the land. It's how we're using our land, and it's important, but we haven't crossed that threshold yet. Fresh water use also is very, very important. We can't live without fresh water. But we have taken measures, and those measures are working, and we now have knocked back the danger. We're not at the threshold that we have been in the past, in 1950s and 60s, when we were talking about fresh water use. Look at this. Biochemical flows, we are off the charts. We've crossed the threshold with biochemical flows. What does that mean? If you look closely, you see nitrogen and phosphorus on the chart. This is primarily from agriculture. These are from fertilizers that are being used on the crops, and then that fertilizer is washed through rain and snow and rivers and streams and concentrated in areas where it is causing a lot of problems. We're off the chart in biochemical flows. Ocean acidification. We need to be concerned with ocean acidification. Right now, we're at a place, if you look on the chart, we're still in the safe level, and that's a good thing, but we need to be aware of it because the acidification of the oceans contributes to the biosphere integrity. So if this were to get out of control, it could be bad news for the biosphere integrity. Atmospheric aerosol loading, we're not really sure. This typically is with regard to pollution. These are pollutants, aerosols from natural sources like volcanoes, for example, kick a lot of dust into the air. Drought, and then the wind from moving across the deserts in a time of drought kicks a lot of dust into the air. A lot of human caused pollutants, air pollution from traffic, CO2 emissions, things like that. Atmospheric and aerosol loading, we're not sure because there are places where it's bad, places where it's not, and we've done a lot of work to mitigate this. Stratospheric ozone depletion. Now, some of you are old enough to remember the disappearing ozone back in the 1970s. We recognized it and we took the steps globally. We worked together as a global family to mitigate this. And while it's still a concern, we now know how to manage it. And you can see that's reflected in the chart. Novel entities, these are things that we haven't even identified yet, that are human-caused reasons for problems in our safe zone, in our boundaries. So when you look at this, what you can see, I just want to summarize what you're seeing on the screen here. The green concentric circles that you see in the center of this graph, these are indicating the safe zone. All of these 9 boundaries must remain within those green circles for us to have life on this planet as we've known it in the past, including us. We have crossed that boundary in 3 ways, and we are getting very close with the ocean acidification. So we are having problems according to this chart. Climate change is there. It is important. We are beyond the zone of uncertainty. We are now in a place of high risk in the climate change. We've not crossed those thresholds like we have with the biodiversity and with the phosphates and things like that. So I want you, for perspective, I wanted to share this with you so you can have a sense for climate change and the role that it plays in our overall well-being as a global society, as a planet. So I think that the chart, those 9 planetary boundaries, I think it gives us a good place to begin. It gives us context. I don't know about you, but for me, it helps me to think of climate a little bit differently. Do we need to be concerned? Absolutely. Are the things that we can do? Absolutely. Is it the most important thing that we're facing right now? Maybe it is better to look at this as part of a system and begin thinking of this entire system as the most important thing that we're facing right now.